All right, ladies and gents, let's get ready to get started. All right. This is one of the most important sections, I think, and it is a continuation from pre-calculus. All of you guys have seen this before. This was section, if you want to take a look at the graphing section, I think it was section 3.6 and section 3.2 in the pre-calculus series that I have on YouTube. And that is Math 1800 at Wayne State University. So at the time I was working for them, and that's what the course is coded. This one is for Calculus 1. All right. So anyhow, so this is a continuation of that story. I will give you a quick view, and this is a very, 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 very important piece of the puzzle. So before we jump in, let me make sure I give you the prerequisites. Those two sections are prerequisite to understand what we're getting ready to get into. All the new stuff are calculus pieces that will come into play. But before we do that, let's review all the old stuff. Hopefully I can do it in seconds. Okay? So here's a guy you would have got the pre-calculus way, right? So I'm going to do it with the pre-calculus method. And you're probably saying to yourself, well, what's the pre-calculus method? Well, when you did this, they said find the intercepts. There were three pieces of information that you needed to find. Was the intercepts, the asymptotes, and then finally, you needed to make the sign chart. And then if you did all this correctly, then you can graph it, okay? So the intercepts for this one, well, the y-intercept when you make x0 seems to be undefined because the denominator is 0, right? So that's no good. So there's no y-intercept is none. The x-intercept seems to be at 1. And how do you find the x-intercept? Again, I'm assuming you guys want to find that. Asymptotes, there are two times. Your vertical asymptote is one type. The other type is horizontal asymptotes. Yes, you guys know the calculus way, but remember, I'm doing this with the pre-calculus method. So they gave you things. They told you to look at the degree of the top versus the degree of the bottom. This will give you a horizontal asymptote at y equals 0. The vertical asymptote is determined by x equals 0. And again, these are the undefined, right? Gave you the denominators. And then finally, you would make a sign chart of this. And what would go on the sign chart would be the zeros and the undefineds. And the zeros were the items that were from the x-intercepts, because that's what zeros are when they cross the x-axis. The undefineds are the vertical asymptotes. So the two numbers that are going on here is 0, which is a undefined, and a 1, which is the x-intercept. Okay, simple enough. Now we would plug in numbers into each interval and figure out what's going on. So I plug in, I don't know, negative a billion, right? I get a negative on top, positive on bottom. That's going to be negative. And this will be positive, and this will be negative. I'm just sparing you guys the detail, okay? So from these pieces of information, you should be able to graph, all right? So let's see if I can physically graph this thing, all right? So let's see if we can hold on to the info, okay? So, graphing it, you're going to draw your x and y axes, all right? You already know that your x-intercept is at 1, 0. Okay, I'm not going to actually plot points. I'm just going from left and right. All this information we had, I'm going to go left and right. So, x-intercept is 1, 0. There is no y-intercepts. There's a vertical asymptote at 0. Actually, I'll pop back and forth. There's a vertical asymptote at 0, so I'll put that in a different color so we can see it. I'll make it in yellow. Yellow seems to be a really good color. Okay, so that's in yellow, and then we're going to switch back here. So that's my zeros, my vertical asymptote, horizontal asymptotes at y equals 0. So that one I'll also put in yellow. So that's just on, again, on the infinities. I'm not going to draw it in the middle because you can cross through horizontal asymptotes. As you guys have seen with the last 60 examples I think we've done over the last 2 classes. And then the last piece, so let's see what I got here. I did my y-intercept, my x-intercept, vertical and horizontal asymptotes. The last piece is this guy. So I'm going to draw it underneath. Oops, went the wrong way. I'm going to draw it underneath. So it tells me that the sign chart, which is from 0 to 1, is negative, positive, negative. Okay, this is an undefined, which let us know we had to have a vertical asymptote. This is a 0, which is why it was colored in here. All right, so now, what do the signs tell us? Well, the signs tell us what's going on with it. So as we go to the left of 0, and I'm going to put everything in yellow that I know for sure needs to happen. This is negative, which tells me it's below the x-axis, so it's going to hug that horizontal asymptote. But now the question is what happens in here? I don't know. It could do a number of things. But as it gets closer to our vertical asymptote, but it better be negative, which is below the x-axis, as it gets close towards 0, it's undefined. And because it's negative, it forces it downward. Okay, so I left a gap there because I do not know what happens in this space. Okay, in between 0 and 1, we say it's positive, so that means it's got a hug here, and I know it needs to touch at the x-axis, so it's going to be touch here coming from above. Again, I left a gap. Why did I leave a gap? You'll see when we get to the calculus part. And then on the right side of 0, it's negative, which means it comes down, but then eventually it has to come back up to do this, right? So everything in yellow on my graph, I'm going to get rid of this sign chart. I'm going to get rid of all these fancy numbers that we collected it from, okay? My sign chart is here, okay? Now here's where the calculus comes into play. In normal 1800, we would say, you don't know how this is going to get from here to there. You don't know how. You don't know if it's going to do this. You don't know if it's going to do this. You don't know if it's just going to be a straight up connection. You don't know those things, right? You don't know how this is going to get from there to there. It could do something like that, or it could do something like that, right? And likewise, we don't know how it connects there. So in 1800, we said just connect the dots and make sure it's smooth, right? But the reality we've learned this semester is that going from here to here, right? What if there's a sharp point in the middle? That means there's a point that's non-differentiable. We might need to look at the derivative to see what those actions that happen that are away from axes and asymptotes. And that's kind of the thing. The asymptotes and the axes kind of let us know where things are, but they don't tell us a great picture. So now what we need to discover, and I'll put it in green for the rest of the lecture, is what happens here. We would normally just connect the dots and say, oh, that looks right. But how do I know how far down that goes? Well, there's this bottoming out point, right? If I can find that bottoming out point, we're in a good place, okay? And if there are some sharp points, then how do I know this is what it looks like, okay? So now, let's get to the nitty-gritty bigger pieces of the puzzle. And what we're going to talk about, the calculus pieces, explain what's happening in these green areas. And that's what we need to do. So all the stuff in yellow, that came from 1800. So you should have already known that. That stuff that's happening in that space, we're going to discuss it now. All right, so how we do this is simply enough by looking at these 4 pieces of information. Now, I will be very, very upfront with you. Names can be very, very scary for people, but I will tell you where we're going to access these from. These 3 things are going to be accessed by looking at the derivative. And this last piece, which will come in the next video, we'll talk about the second derivative. Okay, so I don't want to get into the last piece, but I do want to get into the first 3 pieces, which all surround the derivative. Okay, and what are these 3 pieces? So let's take a look at it. All right, the critical value is literally just the maximum or the minimum value. So in that graph we were just looking at here, when we were talking about, well, how low does it go? The critical values are these spots that can be the lowest turning points or the highest point. So it could look like that, or it could look like something like this. And I'm going to have a couple examples on the other slides so you can see it, right? So that's a maximum, okay? Some things don't have a maximum, like this thing goes up forever, but there's a local maximum and a local minimum that we can find. Those are all called critical values, okay? And why are they so critical? And I'll reiterate this when we get to the other examples, and I think I might be jumping the gun a little bit, guys, but I'm just so excited to talk to you about it, is because all of their slopes are 0. So to find the critical values, these spaces where it bottoms out or turns around or whatever the case may be, we need to look at when the derivative is equal to 0. And why the derivative? Because that is just your slopes. Okay, so that'll be the first big indicator that we're going to need for our new sets of graphs. Last but not least is this guy, non-differentiable points. Well, what are non-differentiable points? Well, let's go back to my green pen for a good dramatic effect. If I had a graph that looks like this guy, classic absolute value, but it might have other stuff going on. I don't know. Well, this spot right here is a non-differentiable point. And why is that not a non-differentiable point? Is because remember the limit from the left and the right aren't doing the same thing. Bottom line, when we look at the definition of derivative. But so that means that, and this is probably the biggest piece of the puzzle. So that slope here is not defined. Okay, so one thing you need to do is look at the non-differentiable points, and those are the places where the derivative does not exist. And normally we would call this the bad number. So remember the old sign chart stuff? These are the zeros. So these are kind of like the zeros. Well, no, they're not kind of like. They are the zeros, but of f prime. And these are the bad numbers. For you guys who remember bad guys or bad numbers or undefined of the derivative. So all of this information ties together. So basically what you're looking for is the information you would use to make a sign chart, but for the derivative function, not for the normal function. And that gives that additional information in space. All right, here's a few examples just so you guys get it. All right, so where is the critical values here and how could it look? Well, check this out. Actually, maybe I'll go back and talk about one more thing. There was one thing that we did not talk about on that slide, and that was the intervals of increase and decrease. So knowing when things are going to be, say, positive. So the derivatives here are positive. The derivatives here are negative. Right? So the slopes, we're looking at the slopes. So if you look at all the tangent lines, all these are like walking uphill. It's all walking downhill. So what that looks like is that's kind of the sign chart. So it gives us the shape of the actual graph itself. And remember, these guys in green are the regular functions, right? The f prime is a derivative of those functions, so be careful. All right, so now let's move forward here. So I'm going to do three things every time I look at one of these graphs. I'm going to label first of all, the maximum or minimums that occur, but the critical values are important. Now, this guy is super important because the critical values is when the slope equals 0. So let me ask you, at which x value does the slope equal 0? You guessed it, the only place that's horizontal is right here. So this is a critical value at x equals 3. So x equals 3 would be our first critical value. Done, right? If you want to know that point is 3, 1, which on occasion they will ask you to label all points. So you should know those, all right? Just by looking at the graph. But you could see that from the left of that graph, if we look at the sign chart wise, there are no derivatives that does not exist. So that's the first thing, right? So we don't have to worry about any of those, right? Because there's no sharp points or cuspy points. But we do know that it is increasing on this side and it's increasing again, right? So, but that's a shape you should get. It's increasing and it has to keep increasing. So this is a big key. So that shape is really, really cool. Okay, so that's my intervals of increase. So if I had to make a sign chart, which we will need the sign chart, I know that 3 should be on there. I know this is a 0, and this is for f prime, not for f, so keep track of it. The graph in red is f, by the way. That is f. So we're talking about the attributes of f. This 3 is that, because we're talking about slopes for the derivative for the sign chart of f prime, that critical value is at x equals 3. The left of it is positive, and the right of it is positive. Now, what's the it that we're talking about that are positive? The slopes. Remember, this is the derivative. All right, moving on. All right, check out this guy. Where in the world is the minimum, maximum, / place where the slope is 0? And if you said here, you are absolutely right. Again, that is also at x equals 3. But on this time, you'll see the sign chart. I think you guys are good enough that I could put the zeros of the derivative. That thing is just at x equals 3. Now, notice I did it by eyeballing it. I didn't really like have a function to work with. Does it have any undefines? Because undefines, after all, is what makes the function undefined or does not exist. That there are none of those. And since there's none of those, there's nothing that goes on our sign chart. So here's 3. Well, the left of 3, the slopes, remember, we're not looking at the values. We're looking at the slopes. These are all negative slopes. This is a 0. Remember, this is where the slope is 0. And these are all positive slopes. Done. That will be the sign chart for this guy. We're going to need this. Piece 1 of 3 pieces. All right. This guy, obviously, it's the same way. Where the slope is, where the derivative is 0 is at 3, right? So it's the same thing, except now to the left of it, we're walking uphill. These are all negative. These are all positive slopes, and all that's all negative. So you notice these are all harnessing around the same number, and this is a 0, obviously. All right, so that means there's a max here, or a min. Something where the slope is 0. Next, these guys, right? Well, here there are no zeros. Why? Where's the slope equal to 0 for f prime? If this is f, where's the slope equal to 0? There are none of them, right? So there are none of these. No zeros. Where is f prime of x? Undefined, or does not exist at. Well, it's undefined at x equals 3. So you'll still have the same sign chart. And this would just be 3, but undefined. The left of sign chart, the slopes are positive, and the right of it is down. It's negative. So therefore, the left and right of that undefined point or that sharp point. But you're going to need to know that when you draw this undefined point, it should look like a sharp point or a cusp point. Really, really simple. Okay. So let's take one more gander at that non-differentiable spot. Okay, and let's actually put this together and into good use. All right. So critical values and non-differentiable points, all right? So look at this guy just drawn, all right? It says determine the sign chart of f prime. I think you guys can do this, all right? I am going to draw this underneath it, okay? So here, and I always like to line my x values up with their x-axis. And there are some points here that has A, B, C, and D on them. So you could see that if this is a sign chart for f prime, I know I'm going to need to look for where f prime of x equals 0. Again, these are the zeros, which means this is where the slopes are equal to 0. And then where is f prime of x? Undefined. So we're making the sign chart of f prime. Undefined. All right, well, good news. This is at x equals a, whatever number a is, x equals b, x equals d. And why do we know that? Well, that's a horizontal tangent, that's a horizontal tangent, and that's a horizontal tangent. Pretty easy. This occurs at x equals c, if you notice right here, because that's going to be an undefined point as well. So that means all the points for our sign chart that we put on have always been the zeros and undefineds. Well, in this case, when we're talking about the derivative, and this is, again, the normal function. So we're looking at the slopes. This would be where a lives, b, c, and d. On the left of a, these are negative. On the right of a, it's positive. And I'll give you a little look at what you're going to deal with on the next video. All right? This is positive, right? But if you notice right here, it's walking uphill, but then it stays constant somewhere in there, and then it starts to slow down as it's like this slope is more positive than this slope, but more in this slope and this slope, until it eventually ends up being 0. But those are all positive slopes. Okay, then switch back to negatives. It looks like for the time being, boom, these are all negative. And then from C to D, they're all positive. And then from D to on out, the slopes seem to be negative. And it doesn't seem like it's going horizontal, even though it looks like it is, but I don't know that for sure. Okay, so this is going to be positive all the way through. So this would be the sign chart effectively, but you need to label all those those values that are on the sign chart, because we're going to use this. So they're not always going to give us f, they're going to give us all the other information, like for f prime and f double prime, and then we're going to have to go back and draw f, which is always a tough thing to do. All right, so label this. This is a 0. Whoops, went back. Go back. This is a 0. This is a 0 as well. This is a undefined, and this is a 0. And then we're actually going to chase down those points to know exactly where they are in space, so it makes life a heck of a lot easier. All right, guys. So really, really simple. This is basically it. So for the first part, we're going to need to look at all the sign chart descriptions for f prime. That's going to give us the critical numbers, and that's going to give us the undifferentiable numbers, because those numbers are your zeros and your undefines. And then we're going to need the sign chart. We're going to need this exact same information for the second derivative, but we'll cover that in the next video. All right, guys. I'll see you on the flip side. Here we go. Start the next video right now. Bye.